All right, so in the last video, we looked at what angle side angle looks like. So now we have an angle side angle congruence to add into our notes. If two angles of one triangle in the included side are congruent to two angles in the included side of another triangle, then the triangles are congruent. So let's put a visual of that in our notes. Here's triangle ABC, triangle DEF. So if you have angle A congruent to angle D, let's say you have angle B congruent to angle E, so there's your two angles. If the included side is also congruent, so the included side will be side AB, and the included side on the second triangle is side DE, we have angle side angle congruent to angle side angle. Then we can state that triangle ABC is congruent to triangle DEF. So that's what your angle side angle looks like. All right, well, let's apply that to a real life problem. We like these. We have a technician that installs cables from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirement? And explain your answer. So looking at the picture, we can see that this is where the technician is installing a cable from here to the ground on either side. To pass inspection, this cable must be the same length as this cable. So does the installation meet the cable length requirement? What we have, because these cables are going down on either side of a tower, we actually have two triangles. And because the tower is perpendicular to the ground, we have a right angle. So let's go ahead and redraw those two triangles. So here's the one on the left. I'm going to go ahead and label that A, B, X. So in the picture, this would be A, B would be up here, X would be down there. And then I'm going to draw the other side. I'm going to label that C right here. Well, this is already a B up here, so that's still going to be B. And then down here is X. I'm going to have an X down there in the bottom. We have a right angle. And actually, we'll have a right angle in both triangles because you can be, if you're perpendicular, that gives you right angles on either side. And then we also know that we have 52-degree angles up here at angle B. Okay, so this BX is right here. BX, that's your tower. BA is the cable on the left. BC is the cable on the right. So does BA have the same length as BC? So what we know is that we have some congruencies already in this picture. We know that angle ABX in the left triangle is congruent to angle CBX because they told us they're both 52 degrees. So I'm going to go ahead and mark that congruency. That angle is congruent to that angle. So far we have an angle congruency. What do you think about two right angles? Do you think right angles will be congruent? Yeah, we have this thing called the right angle theorem you learned about at the beginning of the year, that if you have two right angles, that means they are congruent. So angle AXB, that's this right angle right here, that will be congruent to angle CXB. That's this angle right here. Remember that middle letter tells us the vertex of the angle we're talking about. So far we have two congruent angles. Can we get any other congruencies out of this triangle to show that maybe the two triangles are the same length? Or sorry, are congruent. Do you notice that the triangle on the left has this segment BX and the triangle on the right also has BX. If we look at the picture, that BX is actually the same segment. That's the tower. So that tower is part of both triangles. So what that means is the tower in one triangle, XB, will be congruent to the triangle, or the tower, and the other triangle, XB. So we can say that XB is congruent to XB. That is what we call our reflexive property. If the same segment is congruent to the same segment, that happens when a segment is part of two triangles, or it could be an angle. Maybe you have one angle that is part of both triangles. So do we have congruent triangles? If we notice, I have two angles congruent, and this is the included side. Here we have two angles congruent with the included side. So that's enough information for us to say that our triangles are congruent. So triangle AXB is congruent to triangle CXB. Now that's not what they were asking, but once you have congruent triangles, this tells us that all the corresponding parts are congruent. So now I know that AB is congruent to BC. Those are the cables. Those are congruent because of CPCTC. Corresponding parts of congruent triangles will be congruent. So if they're congruent, that means that they have the same measure. So does the cable lengths meet the inspection requirement? And the inspection requirement was that they were the same length. So yes, the cables meet the inspection requirement.